Welcome to Spring LIB.
Okay, we've got T-butyl iodide reacting with sodium methoxide, or Na plus with OMe minus to give T-butyl methoxide. Or the other way we might have gotten there is with methyl iodide reacting with sodium T-butoxide, which, if you recall, is the following molecule, to give us the same thing, right? And the question is, which of these is possible? Only one of them is successful. What is the successful approach? And we need to explain our choice, right? Recall here that we have a strong nucleophile, right? Because it's charged, which suggests that if anything, this is going to proceed via SN2. And if an SN2 reaction isn't possible, this is also a strong base. So is SN2 possible with this tertiary iodide? And the answer is no. SN2 is not possible because this is a tertiary carbon, which means we can't have a nucleophile come in. There's too much steric bulk. Because this is charged, though, we have to wonder then, we have a strong base, is elimination possible? And yes, elimination is definitely possible. Our strong base can come and deprotonate this proton while the iodine leaves and give us, instead of the product we want, that, right? So this is a competing product. This is the major product of that reaction. We might end up with some of this, but it would have to proceed via SN1. And SN1 is typically much slower than E2, right? And we have a strong base, which further incentivizes E2 and disincentivizes SN1. Now let us consider this option, right? This isn't the strongest nucleophile in the world, but it is a capable nucleophile. It's just a little bulky. But it's charged, and charged nucleophiles are typically suggestive of SN2. And there are no barriers to SN2 here, right? This is a primary primary alkyl halide. That's like the bread and butter of SN2 reactions. Okay, so there's no real issue with this just coming in and displacing iodide. There's no possible elimination side product because there's no neighboring carbons with hydrogens. We don't, SN1, neither SN1 or E1 are possible, or E2. The only possible reaction between this substrate and this nucleophile is SN1, and it will always give that product.